Hi good people, this is Kawes, and in this video the topic under discussion is matter. By the end of this video you should be able to state the three states of matter, explain the states of matter using the kinetic theory, explain the interconversion of states in terms of energy possessed by particles, and you should also be able to describe and explain the process of diffusion. So let's get started. The first question which pops up in mind is, what is matter? This is any substance that has mass and takes up space by having volume. Matter exists in several states, also called phases. These are solid, liquid, as well as gas. Gases, liquids, as well as solids are all made up of microscopic particles, but the behavior of these particles differ in the three phases. These differences are shown in the following slide. Now let's talk about solids. From the previous diagram, we can see that solid matter is composed of tightly packed particles which cannot flow and therefore have a fixed shape. Now let's move on to the next phase, that is liquid phase. Liquid matter is made of more loosely packed particles which can move about within a liquid, but they are packed densely enough that the volume is maintained. Liquids flow and take the shape of their container, and this is shown in the animation video here. The last phase which we are going to talk about is gaseous matter. This is composed of particles packed so loosely that it has neither a defined shape nor a defined volume. In a gas, the particles have a great deal of space between them and have high kinetic energy. When a gas is put under pressure by reducing the volume of the container, the space between the particles is reduced and the gas is said to be compressed. That's all under phases of matter. Let's now move on to the next subtopic, which is the kinetic theory. The kinetic theory of matter states that matter is made up of particles that are constantly in motion. All the particles have energy, but the energy varies depending on the temperature the sample of matter is in. This in turn determines whether the substance exists in the solid, liquid, or gaseous state. It also states that the temperature of a substance is a measure of the average kinetic energy of the particles, and that there are spaces between particles of matter, and the average amount of empty space between molecules gets progressively larger as the sample of matter moves from the solid to the liquid and gas phases. The states of matter are interconvertible. They can be changed by applying pressure and temperature. And the processes involved in the interconversion of matter are evaporation, condensation, sublimation, melting, as well as freezing. The first interconversion process which we are going to look at is evaporation. This is the process by which water changes from a liquid phase to a gas or vapor due to an increase in temperature and or pressure. We also have got the condensation process, which is the change of the physical state of matter from the gas phase into the liquid phase. It occurs when warm air collides with cold surfaces, and when this moisture-packed warm air comes into contact with the chilly surface, it cools down quickly and releases the water, which turn into liquid droplets. Another interconversion process is sublimation, which is the transition of a substance directly from the solid to the gas state. An example of sublimation is dry ice, which when exposed to air directly changes its phase from the solid state to the gaseous state. Sublimation is an endothermic process that occurs at temperatures and pressures below a substance triple point in its phase diagram. At pressures below the triple point, solid ice when heated at constant pressure is converted directly into a gas. And this is shown in the graph here. The next process is freezing, which is simply a phase transition where a liquid turns into a solid when its temperature is lowered below its freezing point. There is also melting, which is the phase transition of a substance from a solid to a liquid. This occurs when the internal energy of the solid increases, typically by the application of heat or pressure, which tend to increase the substance temperature to the melting point. That's all under interconversion processes. Our final subtopic under matter is diffusion. Diffusion is the movement of molecules from a region of high concentration to a region of low concentration down a concentration gradient. An example of diffusion is when nitrogen sulfide in a test tube slowly diffuses into the air of a lab until equilibrium is achieved. The process of diffusion occurs as a result of Brownian motion, which is the random motion of particles suspended in a fluid resulting from their collision with the fast-moving atoms or molecules in the gas or liquid state. The process of Brownian motion is illustrated in the animation video here. That brings us to the end of this video. In the next video, the topic under discussion will be atoms, elements, and compounds. Thanks for watching. Stay tuned for more upcoming videos and don't forget to like and subscribe.